Greetings, future engineers. Today, we're going on a field trip. It's mid-December here in Michigan, and the weather is just about the same as inside your refrigerator, with the addition of gale force winds. This is a hydroelectric power plant. Up above the waterline, nestled away in a warm, well-lit room guarded by 500,000 spiders, there is a generator. 24 tons of screaming, spinning copper and steel. It's been pushing 500,000 watts of power out into the world almost every day since before your great-grandfather was born. But that generator is barely moving right now. It's just lazily spinning like the wheel of a kid's bike right after the crash. And we are headed into the deep, on a rickety extension ladder and a scrapwood raft, because today, that's the job. Normally, this room is filled with water rushing by at over 400 cubic feet per second. That water escapes through a tunnel called a penstock, 20 feet down under the generator, and through the turbine. Today, all that water is being held back by giant steel plates called stop logs, so named because back when this place was built, they actually used wooden beams to stop off the water for maintenance. As you make your way down the ladder, into the dark and the cold, try not to think about the 250 tons of force crushing against those steel plates as they hold back the force of an entire river. Instead, just focus on your hands and the fact that the temperature dropped enough as you came down into this hellscape that now you can see your breath. This is a place that hasn't seen sunlight in a century and will kill you the moment you don't respect it. At the bottom of the ladder, you transition to the raft, barely big enough to hold your weight and tippy as hell. Stand and wait there a minute, while a single oar and a massive wrench are lowered from your helper above. Now that you've got your only two tools, you leave the relative comfort of the ladder and let the current carry you into the penstock, into the dark, towards the slowly spinning turbine. Because now it's time to go to work. This is the wicket gate. Inside, you can see the turbine revolving on the main shaft. This is the lowest point in the stack, and the lowest of 3 sets of bearings are inside those rectangular encasements. These are the quad blocks. These are the state-of-the-art from 130 years ago. Originally, they were made of ironwood, trees so dense they sink in water. The wooden plates would be mounted inside these boxes and held in place with 3 large bolts on each side. The ironwood plates are held up against the rotating main shaft of the turbine and act as water-lubricated bearings. 130 years ago, this was a revolutionary idea. By using wood bearing blocks and water as a lubricant, they turned the problem into a solution. The technology simply didn't exist back then to do this economically or reliably. And because of that, every few months, someone has to make this descent into madness just to tighten the quad blocks. 1 man, a raft, and a single wrench to give just half a turn to a dozen bolts. Engineers of the future, you can do better. As you design things, it's important to think not only of how they will be built, but how they will be maintained and repaired. This set of bearings could have been located within an enclosure accessible from above. In our entire fleet of power plants, this is the only generator where the quad blocks have to be accessed from below the housing. It's not a big difference in design, but it's a huge difference in operation. A stroke of the pen, a click of a mouse, a few minutes of critical thinking. That's the difference between a man doing this same job in 10 minutes as a menial everyday task, or risking his life to spend a whole morning just to tighten a dozen bolts. That's the difference between these same bolts getting checked and adjusted every few weeks, or put off for months at a time. The more often they're checked and adjusted, the better things run and the more reliable the power plant is. It's the difference in quality, reliability, and safety. And it all starts with you, young engineers. This is your duty. This is your legacy. To the generations of tradesmen who will create and maintain the things you imagine. remember the man who toils down here in the dark and make it easier for the next guy. Thank you.